I'm Joanna Regal on behalf of the Eastern Transportation Coalition. We welcome you to the RITIS Quarterly User Group web meeting. Just a few things. We are using Zoom webinar. You can join with audio either through your computer or phone, whichever works better. Please note this web meeting is being recorded. If you have any questions about the web or audio, please reach out to Esther. So to ask a question, we're going to be using the Q&A box. You just simply type your question in and the Q&A box will be monitored. We're going to answer questions in between presentations and at the end. If you'd like to ask a question verbally, please raise your hand. That brings you to the top of the list and lets us know that you have a question. At this point, I'd like to turn it over to Denise Marco. She is the TSMO Program Director for the Eastern Transportation Coalition. Denise?
Thanks, Joanna. Can you hear me?
Yes.
All righty. Thank you. Hello and welcome to everybody. We have a lot of jam-packed information today, so I'm going to be quick. As usual, we always talk about some of the coalition updates that we have going on. These are some of the recent events. Everything you ever wanted to know about traffic signals, performance measures. We held that on November 9th. But large number of people participated. Information's on our website if you want more information about the slides or what went on. And then, of course, over the past couple months, we were holding meetings, in-person exchanges with our highway operations group. We did one in Potomac in October, one in the Delaware Valley, Philadelphia region in November. And then we did a 1.5-day meeting in North Carolina in the South. These focus on traffic incident management and are known for being great networking events with a lot of emphasis on incident management. The TDM marketplace, again, we're very active in meetings that we're doing with the validation program. Stan Young leads that. He runs a vendor meeting. We have a state point of contact meeting every 6 months that talks about contracting, new products that are coming in. And then we have a validation tech advisory committee meeting that really discusses what's going on in the validation program and from the data perspective. So a lot going on there. And obviously RITIS, our after action template. We had an after action template workshop. Rick Ayers led that, very popular, very well received. I think we're looking to do another one, something similar in the spring. Waze and Google, we do a lot with them in terms of product development. We work with their engineering and their product teams. We had an update meeting in January, to talk about what's going on and where they're moving forward. We are working with Google now as well as Waze. And then lastly, last week, we had an info sharing event called the Next Gen NHTS OD Data, Overview Products and Use Cases. That's a mouthful, but it was a very well-received discussion about the work that's being done in the mapping area there. So, next slide, please. And what we've got coming up. Next month in February, we're holding an vendor forums for analytic platforms. We've got 2 dates set aside, February 9th and the 23rd. We have 4 vendors on the 9th, 4 vendors on the 23rd, each giving an overview of their platforms and their analytic platforms and how they work. RITIS Enhancement Working Group meeting, that's an invite-only meeting on March 2nd that talks about ways that states can provide funding to help improve the RITIS platform. We've got a travel information virtual info summit on March 16th. That's going to focus on a couple things. One Network is coming in to show a presentation of how they integrate data. We have Pennsylvania Turnpike talking about lane configuration, integration for Waze. And then we have a session on truck notifications and how the programs that are being used for getting alerts out to truckers. A strategic planning session is set up and being scheduled for April 13th. This is where you weigh in on next year's work plan and what we want to do. And then there's a RITIS workshop in April. That's more info is coming soon on that. That's in development. I believe Rick Ayers is the lead on that. And lastly, a summit on May 8th and 10th. This is a large conference. It's a 3-day conference. It's designed to focus on, again, safety, distracted driving, move over laws, emerging technologies for responders. And that's going to be held in Baltimore in May. All right, I think that's a mouthful. But with that being said, the next slide, here's the data marketplace update. There's a web page that you can go to. It gives you all the information about our data sets, about our vendors, and the automated DUA process to get access to the data through the marketplace. So these links are important for you. And Esther, it looks like, has put that information in the chat box as well. Next slide. So with that being said, I'm going to now turn it over to Matt Glasser, who is one of our great co-chairs for the Data Tool program. He's the National TSMO Account Lead for Arcadis. He also is one of two of our user group co-chairs. So Matt, that being said, you want to take it away?
Appreciate it, Denise. Thanks a lot.
Welcome.
And I apologize to all the participants today. You have to see me twice in a row, subbing in for Jesse. But we're really excited to have everyone here. As always, great turnout. And we'll show that here on our next slide, if you would. As always, you just heard from Denise, welcoming you. Our spotlight presentation this quarter will be about the National Capital Region's 12-year bottleneck analysis, and Andy Meese will be doing that for us. Mark and Michael will lead us into a conversation about our user delay cost calculation methodologies and some improvements that they're working on. John Allen, as always, will be discussing some of the performance measures, working group updates that we've been working through, and Bob Frey will touch on the overall RITIS pooled fund product enhancement working group that he's leading. And then to round us out, Michael will lead us through a few different pieces. One, again, being the new tools and enhancements that have come online, as well as what's coming up. And then finally, we'll be looking to get some input from the agencies like we do every meeting. Next slide, please. So let me go ahead and run through today's speakers. Up first, the infamous, the one and only Michael Pack, director of the CATT lab at the University of Maryland, where he works to make transportation data more easily accessible and usable by ops, planners, and researchers. He has previously worked at the University of Virginia and the Oak Ridge National Laboratory. Andy Meese and his team at COG help support the National Capital Region's Transportation Planning Board, or TPB, the officially designated MPO for Washington, D.C., suburban Maryland, and Northern Virginia. Andy leads several transportation planning areas under TPB, including performance-based target development, congestion management, technology, safety, bicycles and pedestrians, public transportation, and freight. He holds a Master's of Urban Planning from the University of Michigan and is a member of the American Institute of Certified Planners. Mark Franz earned his BA in Physics and BS in Astronomy from the University of Florida and his Master's from West Virginia University and his PhD in Civil and Environmental Engineering from the University of Maryland with an emphasis in transportation engineering. John Allen serves as a liaison and educator for the CATT lab at the University of Maryland. John also assists in user experience, user interface development, quality control, and quality assurance, manages special projects, and aids in developing strategic directions for RITIS and the PDA suite. Before joining the CATT lab, John was a section chief of the Bureau of Commuter Mobility Strategies at the New Jersey Department of Transportation, with over 30 years of experience in planning, corridor analysis, and system mobility. And last but certainly not least is Bob Frey. Bob has worked in a variety of roles at MassDOT's planning office for more than 2 decades. Most recently, one of his focus areas has been vehicle probe and GPS data as he manages MassDOT's RITIS contract and participates in various coalition meetings for the last several years. Next slide, please. And it seems like every meeting this list continues to expand. Right off the top of the bat, we have 13 of our TETC member agencies represented, along with a whole host of additional groups that are attending that ride on those contracts, as well as some folks as far out as Alaska and Ohio. Very excited to have you guys here, along with some representatives from Texas as well. As you can see right now, we already have 90 participants on, but we're hoping to expand that number over the course of this with over close to 160 folks registered. Next slide, please. So as always, we like to get this started with a few poll questions, and we'll be bringing those up. I get to stumble my way through reading these for you guys. But the first one that I don't get to answer, but how often do you attend RITIS user group web meetings? 1 to 2 times per year, 3 to 4 times per year, or this is my first meeting. I'll leave that up for about 30 seconds or so. Let you guys click on it. And Joanna, let me know when it starts slowing down so we can move on over to the next one.
Yeah, I think we can share now. We can
Okay.
close and share.
Oh, much different makeup. Normally this is like a bell curve, but almost almost an even split between 1 to 2 and 3 to 4. But certainly glad to have a nice size of folks that this is your first time attending. Let's go to the next one. Second poll question: how do you use the data and the associated visualizations from RITIS? We use those results directly from RITIS to develop products like reports, maps. We download the data and use our own agency's tools to create tables and visuals for product development, or we do a little bit of both. Again, Joanne, if you would, just let me know when that starts slowing down and we'll share the results.
Sure thing. Just waiting another couple seconds. All right, I think it's slowed down. I think we can stop this poll and share those results.
Excellent. All right, a little bit of both takes it. Over 2/3 of our folks do that. That's great. It's certainly been on the rise. And our last poll question: who is your primary audience for sharing information that was developed from RITIS and the PDA suite? Unfortunately, you only get to choose one. Got to force you there, but we do it for our peers, our direct management, our executive leadership, elected officials, or mainly gear that towards the general public.
Just give a few more seconds. Folks are still voting. I think it's the having to pick one, Matt.
It's tough. That's a tough choice.
Yeah. Okay, it looks like we stopped, so we can share that poll, those poll results.
All right. Looked like a pretty good mix up in the top 3: peers, management, and executive leadership. Appreciate that feedback. It'll certainly help us do some additional development. With that, I think we can go right on into our presentations. Andy Meese, I'm going to hand it over to you.
Good afternoon, everybody, and thank you for the opportunity to present today on the National Capital Region 12-year bottleneck analysis. Next slide, please. Again, Andrew Meese, or Andy, as Matt said in the introduction, I work for the National Capital Region Transportation Planning Board. We're the MPO for Washington, D.C., suburban Maryland, and Northern Virginia. As he mentioned in the intro, give you sort of a size a size estimate there, about 3,500 square miles and 5 million population. And one of the confusing things is the MPO is a named board at the Council of Governments, but is not, does not equal Council of Governments. We staff the MPO here. Next slide, please. So what I'm going to talk about today, this bottleneck analysis actually grew out of a report that we do every 2 years, the Congestion Management Process Technical Report. And this gets delivered to our main technical committee, which indeed is called the Technical Committee. And it came to them on schedule in the middle of this year, June, July of 2022. And for some reason, the one thing that they did talk about in their review meeting was one of the 200 and some pages of analysis was a bottleneck analysis. And specifically, we think this grew out of the fact that previously, and it goes to that poll question, we had just downloaded data and done our own methods. But with the built-in tool in the Probe Data Analytics suite, we decided to shift over to that tool instead. And you shift tools and results can change. And so, they got some unfamiliar results in the top 10 bottlenecks. Asked about that. We said, well, it wasn't really feasible to redo the analysis with the old tool. But you know what? We have an opportunity now that there's 12 years of data in the tool that we can go back and do a longer term analysis and see what happens. So after a few months, we came back with the results of this analysis, put it in the read-ahead package in draft form for a technical level committee. And as you'll see in a moment, we did not anticipate that it was going to go viral right then and there. Next slide, please. So actually, we approached this in twofold, not only to look at what the results were in actual bottleneck ranking, but a little bit about how the tool works and what some of the options are. And I think any of you on this call have used it know that what you're going to do if you turn on the Probe Data Analytics Bottleneck Analyzer is that access to whatever data. We are fortunate at our MPO to have access to a robust set of INRIX data, thanks to investments by our 3 states, District of Columbia, Maryland, and Virginia. So we get that. Data is available to us, and it's given in a traffic message channel network form. We'll talk about that a little bit more in a second. We have to develop a network, which is certainly far from trivial, well over 14,000 TMC segments. But once that's done, then it's saved, it can be reused. And you push a button and the tool produces a ranking table and maps of bottlenecks. And those rankings can be sorted by several component factors. Next slide, please. So this is an example of the results page the tool gives you when you run a bottlenecks analysis. I know it's a little bit difficult to see on the screen, not really meant to look at the details here. But on the left, the ranking and locations as whatever it has come up in your analysis. And you can see a little bit of a map there. Which I'm not going to dwell on today, but I do want to call your attention to those several columns, and there are factors at the tops of each of those columns. Those are, ranking factors, and you can actually hit a mouse and resort the entire table that it's giving you based on a different ranking factor. So there's not just one bottlenecks analysis, there's many different options that you can do there, and there's different factors that you could weight on, like total delay or speed differential, things like that. So as an analyst, you want to pay attention to that and choose. Next slide, please. Here's a little bit more about those ranking factors, and 3 of the ones that we think that were prominent. Congestion. And I don't know that I have the math skills to understand exactly how these are calculated within the tool, but to my judgment, that emphasizes queue length and speed drop. Total delay emphasizes speed drop weighted by traffic volumes. And then there's something called base impact, which is queue length and duration. And our eyeball method, as it were, judge that to be closest to what TPP has done traditionally, which was based on aerial photography analyses. And so we sort of gravitated to that ranking factor because the results reminded us of what we saw before. And we'll have a little bit more on that in a second. Next slide, please. So again, we had the access to the INRIX data, and now that we had 12 years worth of data, now in the bottlenecks analysis, you're limited to 1 year at a time. So we did 12 one-year analyses and then looked at those across. Used base impact, as we said, and we took as our base what we had actually published in this congestion management process report back in July. So a lot of the things that we were looking for compared to what had been published. So some of the things we were looking for is whether bottlenecks over that time were persistent, were they short-lived, the comparative severity and the trends. So next slide, please. Here's a first thing, and this is an actual offline tool. We actually used our own ArcGIS to create this top 30 locations, and the message here is that there's a few places that come up often, and there's a lot of places that came and went in 12 years. And so there's a variety of situations that come up in this sort of analysis. But interestingly, we had one location that was the #1 bottleneck all 12 years. And there it is. I don't know if anybody's familiar with it. I-95, just south of at the south end of the Washington region at Virginia Highway 123, exit 160. And we'll keep seeing that again in some of these other slides. Next slide, please. So I'm repeating this same screenshot slide because I want to again use it introduced the analysis that we have in the following slides. And again, as an analyst, you can click on those column headers and resort the the ranking list, and you may have very good reasons to do so or have a different sort than we have. Next slide. Here is, you might call it a sensitivity analysis of hitting those top of the columns and resorting. So the left here is what was published in our report. The top 10 bottlenecks, their identities, the rank, again, ranked as we did by base impact. A couple of different criteria. How about total delay? Well, the list does change, although maybe not so radically, but you can see that some things go up and down. But if you go to max length of queue, for example, boy, those numbers look really different. And, there's all sorts of different factors in bottlenecks. Queue length is one of them. Duration is another one. Frequency is another one. And all those things can go up and down as you change these lists. So when you read, in the press, it's like, oh, there's a number one bottleneck. Well, depends on how you want to rank it. So we think that this was interesting. You can see how different those results are. Next slide. I think this is what, our committee was very interested in, is like, are bottlenecks persistent over time? What's happened with them? And you can see we had that one ever-present number one bottleneck, but a lot of other locations had their turn at number two. Had a couple of new ones, but as you can see, we had quite a few that are recurring. So we do know that those, happened over a long time. And there is that footnote there. Once we get big numbers, especially if you've got a 12-year trend and it was highly ranked in that second one, 8 years, but one time it really dropped to the bottom of the list. Wait a minute, what's going on there? Perhaps a data glitch as opposed to something that's really happening there out on the road. So you got to watch the data. You can have missing data and so forth that can come. Next slide, please. Here's another view of the similar data. That top table are 5 most frequently occurring bottlenecks off of this analysis. But I think a more interesting question for the committee is, well, have we really resolved anything? Have we made some progress based on improvements or programs that are out there? So here were 5 locations that had been highly ranked on bottleneck lists, in the past, that had sort of dropped down in recent years. And 3 of those were on I-66, where there were a number of improvements, and interestingly, things that had to do with conversion to HOV lanes, to high occupancy toll lanes, and so forth, in addition to physical improvements. So those were the locations that seemed to have the most dramatic improvement. But that was interesting to be able to see. Next slide, please. Why do bottlenecks change over time? I would presume that a lot of people on this call could explain these as well. But I think the message here is that the capacity and engineering of a specific location is those are definitely important. But there's a lot of other factors, some of them far away, that can be in play here, like national trends and even year-to-year variations in the storms. Not to mention, does the PDA suite tool change over time, or its underlying databases? That can happen too. And some of this is, from our perspective, is a little bit in a black box. So if we're going to repeat this analysis over time, that's something we want to watch out for. Next slide, please. I think this is interesting. This is a very different look, and just to make it interesting, I chose 2019 data instead of 2021. This is comparing the magnitude. Now, this base impact is a multiplicative product of a number of factors. So you get these big numbers, and that's what they are. And we did this waterfall graph on Excel, and you can see here that our number one bottleneck is not only number one in rank, it clearly is number one in magnitude. I mean, twice as impactful, more than twice as impactful as the second ranked one, and something like 4 times as impactful as something that's at number 10. So that was interesting to see as well. And by the way, we are aware of the many efforts by the Virginia Department of Transportation and partner agencies that they're pursuing in this very challenging area. So, this is not to say that it hasn't been paid attention to, or that there haven't been programs, whatever. It just happens to be, have a number of factors that lead it to be a significant bottleneck. Next slide, please. Just a quick look at some of the major projects that had occurred during this 12-year period. The one that we saw the most evidence of, I think in this particular analysis, were the I-66 improvements, but hopefully these others have helped congestion management, even if the relative rankings didn't change that much. Now for this next slide, for I think this group, some of the caveats that we had in this tool. Only 1 year of data at a time is allowed under the size of the tool. Would have been nice to do a whole 12-year analysis, but we didn't do that. And you can screen out days of the week, but it's sort of simple. You can screen out a day of the week, but you couldn't say screen out federal holidays, which would be something we might be interested in doing. And in comparing to things that we do in our modeling and so forth, where we do that. I've already talked about the issue with the traffic volumes, or actually I will in a moment. That when you look at the traffic volumes that are contained in the database for this kind of analysis, I wouldn't recommend using them. They're sort of inconsistent locationally over time. We'll look at that again in a second. Traffic message channel, for anyone who's used these networks, they're far from perfect. They're, even if they're correct, they still have a lot of different lengths and so forth that can have mathematical artifacts. And of course, you can have errors, missing links, this kind of thing. And one thing that is particularly notable in our region, we have a number of reversible lanes, and the data just aren't right in reversible lanes for an entire day's analysis or entire year's analysis. We get unreliable results, and so we just have to take those off the top. And all of these caveats are not to say anything bad about the tool. This is a very handy and useful tool that we appreciated being able to use. Next slide, please. Here is a visualization of the volume issues. There's 3 lines on this graph for our famous exit 160 location. These should all be the same theoretically because they're the volume at the same place. And 2 of the 3 are basically the same. The federal HPMS and the Virginia Department of Transportation source. That flat gray line on the top is what you find in RITIS. And this is not to be harsh with the RITIS staff, the University of Maryland staff. They only have the data that people provide to RITIS. But these are the reasons that we actually shy away from things that are depending on volume in this kind of analysis. Not only is it not consistent over time, but if you start saying, is it right to apply a 2019 volume to a 2011 level of congestion? It's not simultaneous. And that's on an annual basis, let alone when you're analyzing something like a storm, or some short period of time. There may be reasons why you feel confident using volumes, or you have volumes, from your own source, but we didn't use the built-in ones. Next slide, please. Now, turning to the going viral, we had some unanticipated media attention. As I said, this was posted in draft form as read-ahead materials to a technical committee. That happened to be December 2nd. And shortly afterwards, staff was notified that a local television station had already done both an online story and a television news segment trumpeting what the #1 bottleneck was in the region and so forth, months before we were even contemplating it going to the COG board. So this was, I guess, a lesson of sort for us. And there was echoing coverage by other media outlets. People started asking questions that weren't necessarily supported with what we had researched. In this relatively short analysis. The analysis was to look at the sensitivity of this tool, not so much to do a deep dive into why bottlenecks, the bottlenecks that are there do exist. But it does show media loves rankings, even if we would prefer to tell the more complex story about congestion and congestion management strategies. So if you're looking for attention, maybe something like this does get some attention. Next slide, please. And just from my heart, I really want to talk about the context of this. Bottleneck analysis is just one little bit of congestion management. We do the other, analytical options that you find either in the suite or elsewhere in the literature, using travel time index, using planning time index, defining corridors and looking at travel time along those corridors. And of course, our report features not only the data, but also things about the strategies. What do we do in our region to try to address or manage congestion? And that features our commuter connections program. We have a whole suite of things with carpool matching and transit support and so forth that's gone on for many years in our agency. That is, really a big part of the message here and what we would take to our board when we get there. Next slide, please. I would like to acknowledge my colleagues who helped very greatly in all of what you saw here: Janmu Lee, Patrick Ziliakis, and Eric Randall, and of course, everyone over there at the University of Maryland, all your developers and support personnel for making such a fine system that we could do this with. And that concludes, next slide, that concludes my report. And Matt, I would be glad to either look at questions or go on to the next presenter as you prefer.
Yeah, I think we have a few moments to take a couple questions, and I'm going to selfishly start and ask you, when you guys did the bottleneck, admittedly some of these are massive interchanges. Are you looking at all of the legs, or are you just, when you were building those numbers, or were you only looking at a single approach?
I don't know that I have the ultimate expertise to answer. Other than that, we have a network created, and we put the network in there, and it spits out what it thinks are the top bottlenecks, and it goes through some complex analysis of I call it sewing together different TMCs, right, to get a bottleneck. And I think that methodology sort of favors the main lines as opposed to the ramps or something like that in this sort of ranking. It's sort of I would say it's a mixed answer. If you've got a big enough ramp and it has enough congestion, maybe it's going to show up. I mean, if you're doing a different type of analysis and you want to look at the ramps, you might find that. But I'm not sure that those shake out in this sort of region-wide analysis.
Gotcha. Well, let's head on over to the questions that are being posted. It looks like we already have quite a few, and a couple from Kelly Wells from North Carolina. Did you end up having any locations where you had overlapping bottlenecks? And if so, how did you end up handling that?
Okay, well, I mean, that's a great question. I guess we did whatever the tool does with that, because it's determining through its mathematics where is ahead of a queue and how long does it last and how long does that relate. But it also does relate to, if you're looking at this analysis over time, those little shifts can make the mathematics shift the head of the queue a little bit. You would get something, maybe with a construction zone, it would catch people off, a mile ahead or something, and suddenly that bottleneck would change, and then it would change back. That's probably the best answer that I could say, is that, in terms of what the bottleneck is, we do what the mathematics of the tool told us that it would be.
And then a follow-up was, did you do anything special to denote bottlenecks that were caused by long-term construction projects?
Not specifically, other than to try to cross-compare with some of those, those major improvement lists, or just our own sort of knowledge. And I think the hint is when a bottleneck location would come and go over a period of 12 years, that was probably a construction zone, but not a deep dive.
And then looks like the next question that we're going to hop to, did you analyze for recurring or non-recurring congestion?
So we did 1 year, 1 year blocks of time. So I think the answer is that the non-recurring congestion are probably going to wash out in year by year chunks, right? You're really looking only at the recurring.
Perfect. We have one last one. Of course, as you have more questions, as the audience has more questions, we'll be keeping our eye on it. But the last live question that we'll answer, did you develop an intersection score combining all TMCs, especially at signalized intersections?
I don't remember any discussion of signalized intersections. We just have a network of TMCs that have data, INRIX data available to us, and put it in the tool and let it tell us what it found. But what the engineering of those specific ones, other than taking the reversible lanes off the top, I think the mathematics of the tool tend to favor limited access highways for whatever reason. And it is a little interesting, in 2020, which, had such odd results with the pandemic and everything, that when we looked quarter by quarter with one of our analyses, you started to see more arterial highways. A lot of commuting was down, and things started bubbling up on the list that were like in front of shopping centers, this kind of thing. But that really came and went pretty quickly. And these evergreen bottlenecks on major freeways, commute routes, intercity travel, whatever, keep dominating the list. Now, if we did a top 50 or top 100 and did lots of studies, maybe we would get into that more.
Excellent. Well, again, for the audience, please feel free to ask some more questions, but we're going to go ahead and get on to our next speaker. Hand it off to Mark and Michael to start walking through the user delay piece. So, gentlemen, we're off to you.
Thanks for the introduction, Matt. So it's a nice segue from Andy's presentation into what I'm going to be talking about, even though the focus is on the impacts on user delay cost. The primary component that we're going to be talking about today is in our user delay cost algorithm, controlling the volume, called volume limiting, and that's sort of going to be the focus of the presentation today. So just a brief summary of what I'm going to be talking about today, give you a little bit of background on a new methodology that we're considering integrating into our user delay costs. It's called the car following model, and I'll give you some background on what that is and how it's different from what our existing algorithm is. And then we went through and did a validation of our car following model to see how well it compared to volumes that we got from well-calibrated ATR stations in the state of Maryland. So why are we talking about this today and considering making some modifications to our UDC algorithm? Well, it all started with our work on the causes of congestion graphs, the causes of congestion pie chart deep dive tool, essentially, in probe data analytics. So while we were building that tool, as Andy had mentioned, it's very important that agencies, when able, send us their updated AADTs and volumes. They have tremendous impact on user delay costs as well as bottleneck ranking. So we encourage them. I actually met with all of the independent states to figure out what volume data they ultimately wanted to use, because everything in cause of congestion graphs was pre-calculated. So in relation to that, before we kicked off this huge processing job to do the cause of congestion calculations in the pre-calculation step, we wanted to take a look at how well our UDC algorithm was working, and specifically looking at with the volume limiting equations. And that's actually, if you guys are familiar with it or go to the help page, it's one of the component of the user delay cost that we probably get the most questions about. It's derived from a traffic flow model. It's not the easiest to follow. And so we wanted to go back and take a look at that to see if that was the appropriate volume limiting strategy. And I'll just mention here that the ultimate goal for CATT Lab is to have real-time volumes on every single road, for all of our clients, but we're just not there yet. We don't have enough ground truth data to calibrate the models and support something like that, but hopefully we'll continue to work through that. So I'll just briefly talk about why volume limiting component of this algorithm is so important. So let me start by saying the way that our volume estimates work is based on a profiling method, and it's pretty well accepted method. It was developed by the Texas Transportation Institute, and we adopted it. And it basically breaks down the AADT by percentage for each hour of the day. And then we can adjust that based if it's, that particular TMC or traffic message channel is AM peak heavy or PM peak, or if it's a freeway or a non-freeway. This is just one of the charts that we have that shows 4 of our 16 profiles based on the different characteristics of the roadway. And we've shown in the past that this profiling method can provide fairly reasonable estimates of the volume under normal conditions. So if your historical pattern at that segment is fairly consistent, the profiling method works fairly well. But it does not really do a great job when something abnormal happens. And that could be for various reasons. Could be because of a crash, a work zone, weather-related stuff. There's just a surge of traffic on a special event day. There's different causes for it. So when that happens, obviously that the historical AADT might not be able to actually traverse the road segment that we're analyzing because of congestion and because of the speed that they're moving at. They can't get across the full segment each minute when we get the data. So we tried to develop some algorithms to help us better handle that. So when it becomes abnormal, we can sort of throttle the number of vehicles that are kind of stuck in one segment under congested conditions. So these are just screenshots that I took on the RITIS platform. The same road, you can imagine they were taken at the same time on different days. You can see on the left, things are moving fairly free flow. And on the right, at that same time for that same day, it's pretty congested. And this is the situation where we would have to kick in the volume limiting because that full demand is not able to be served given the prevailing conditions on the roadway. So we started by looking at, okay, what is our current volume limiting algorithm doing? Is it accurate? Is it not? So to do that, we look back at ATR stations from the state of Maryland that are used to submit to the HPMS. So they're pretty well calibrated, can be treated as a ground truth. We did this in 2019 to stay away from any impacts of COVID-19 travel. And then we compared that to the outputs of our algorithm in terms of, after we get the volumes, we take the delay that's observed on these segments and then come up with a comparison on the user delay cost. So you can see there's 16 that we looked at, couple of different road classes and throughout Maryland. So there's both urban and rural roads that are included in it. So we did that on purpose to try to make sure that, test our methodology in various different scenarios to make sure it was robust. So when we did our comparison for the entire year of 2019 at these 16 stations, we found that PDA was apparently underestimating the user delay cost when we compared it to the volumes that we got from the ATR stations themselves. So this was, an impetus for us to say, well, what can we do to make it closer to the ground truth, right? So we got together, came up with a few ideas, and one that we came up with was a car following based model. So it's just based on pure physics and driver reaction times about how close cars can follow each other under certain speeds, and use that to figure out how many vehicles can fit in a given segment traveling at that speed and how long it would take them to traverse the entire segment. So let me just, my intention is not to get into the weeds of the equations. I don't want anyone's eyes to glaze over. So this is a very high level introduction to the car following model and the concepts. If you are interested in details, we can certainly have a follow-up call. Feel free to contact me after today's webinar. So a couple assumptions that we made for our car following model is that as congestion increases, the speeds will drop and vehicles tend to follow closer. And again, this gets back to the perception reaction time. If you're driving slower, you can follow a little bit closer because you can bring your car to a stop if the car in front of you slams on its brakes. So different concepts for high, moderate, and low speed are shown here. And our second assumption is for a given speed that cars can follow closer than trucks. And again, it gets back to like, stopping a heavy truck with the forces and the weight of the truck. It just takes it longer to bring it to a stop. And if the operator of the truck is driving safely, he'll leave that extra buffer space more so than a passenger car would likely do. So just a quick overview of the procedure itself. So step one is we estimate the spacing of passenger and commercial vehicles. So getting back to that last slide, for a given speed, what's the spacing between following vehicles, right? And then after we do that, we add in the length of the vehicles. So we have a default for commercial vehicles, I think was maybe 65 feet or 58 feet. I have to look back to know that. And then for cars, I believe it was 20 feet. And we add that to the spacing. So that's the total lane length that's consumed by a vehicle following another vehicle. And again, that changes with different speeds. The next step is step number 3 is we compute the number of passenger commercial vehicles on each segment. So we do it lane by lane, how many would fit, and then we multiply that by the number of lanes for that road segment that we're looking at, and it tells us the number that can fit in that segment. But then the next step is not just taking a snapshot of how many can fit, because we get the data minute by minute. We have to figure out how long it takes the vehicles to traverse. So if it's a somewhat long segment with a slow speed, it might take several 1-minute time periods for a single vehicle to traverse. So we have to handle that traverse consideration when we do the estimation of how many vehicles are experiencing that speed for that minute. And then last, we compare the car following model with our historical profile to pick the minimum. So if we don't always have to use volume limiting, right? So if there's not congested conditions, we can rely, or more abnormal congested conditions, we can rely on the profiling method. But it's when it becomes an abnormal amount of congestion. So we only use it when our profiling method, we suspect that it can't handle it on its own. That's when we kick in the profiling method, or I'm sorry, the car following model. And as a heads up, we did actually, because we found these results, and I'll show you the validation in a moment, we did decide to use the car following model volume limiting equations when we pre-calculated our data for the causes of congestion graphs tool. So the results that you see in that are a result of the application of the car following model. So after we developed the model, we obviously wanted to validate it and compare it to the sort of as is volume limiting equations that we have in Probe Data Analytics. So again, we use the same sensors. We did this for multiple different time periods. We did it for a day, for a week, for a month, for a year. The results that I'm going to show you are from a single day, but the pattern that we saw is not really impacted by the temporal aggregation. And here's what the results look like. We also broke it down by different functional classes. What we noticed was, well, first you can see the car following model is generally a lot closer to what we would get if we were used ground truth volumes from the ATR stations. And still, the PDA is the same one that I showed earlier, but just showing it here as a reference point. You'll notice too, when we break it down by functional class, that the difference is a lot bigger in function class 1 versus on the right, we have function class 3. And what we noticed is these sort of extreme or abnormal congestion events tend to happen more frequently, as you might imagine, on major freeways in terms of impacting the volume limiting. So it usually kicks in on function 1. It does trickle down to some of the lower functional classes, but it's a little bit more rare to see the car following model being applied. We can generally use the standard profiling method to capture what's going on the lower class roads. So the main takeaways of our analysis is that our current volume limiting algorithm, as implemented in the Pro Data Analytics Suite, is likely underestimating user delay costs, and that's especially true on function class 1 roadways. The car following volume limiting method is close to the ground truth in the PDA volume limiting equations. And based on that result, we're recommending, or at least considering, changing the current volume limiting equation across everything in PDA to the car following model so that we can get a better representation of the vehicles being impacted by bottlenecks. So I wanted to intentionally leave some time, for questions and comments on this. Again, it wasn't really meant to go into the weeds, but more to introduce the idea of the car following model and the potential that it has to improve some of the products that we have in Pro Data Analytics. I'll be happy to take any questions or comments.
Hey, Mark, before we get into the questions, and there are a few, I just wanted to reiterate the fact that, this is an improvement. It's going to be more representative of what's actually happening on the roadway, but it does have an impact. The impact is that, it's going to look as though there's more user delay cost on the road for, once we implement this, and which could impact prior user delay cost calculations. So we're trying to figure out a way to make perhaps both versions of the algorithm available for a period of time, but also make sure people have the ability to go back in time and rerun past queries. There's a lot of messaging we need to do as well with everyone to make sure that they understand that there's a cutoff point, and here's what the implications mean for user delay cost calculations moving forward. Otherwise, it might accidentally look like there's suddenly millions and millions of extra dollars worth of delay out on the roadway when that's not necessarily the case. We're just undercounting it earlier.
Michael, to take that a step further. So let's say that someone runs a user delay cost now on a roadway, and then tomorrow this is implemented within the PDA, and they were to go back and run that same query. That's when it's going to show up, right? It's like that analysis that they did, let's say on January 1st, 2023, if they run it day 1 versus day 10, that number is going to change. Is that what you're indicating?
Yeah. So if you run a query today for the same date range, if you'd run a query prior to us implementing this, you'd get 2 different results. Where the new results would be much higher if you're looking at functional class 1 roads and there happened to be a lot of congestion. And it'd be a shame if someone did a before and after study where they ran a bunch of queries before they started construction, right? And then they do the construction, and then they run a bunch of queries after they did the construction, and it looks like things got worse. That's not what's happening. You just need to go back and rerun those queries. Anyway, we will do more messaging. We will do more discussions. We will do more analysis as we get into this change. But we wanted to let people know that we think that this is the right thing to do, so that it can be more accurately representing delay out there.
Let's hop into a few of the questions since we have the time. And the first one was, does a car following method consider transit vehicles, and how about vehicle occupancy?
So it does not include transit vehicles. The way that our UDC currently, the full algorithm, it has just passenger vehicles and commercial vehicles. And they're based on percentages, so it doesn't directly handle transit vehicles like buses. And the second question was, I'm sorry, Matt, can you repeat?
Has to do
Let
with
me go find it.
had to do with vehicle occupancy.
Oh, occupant. Yeah. So the UDC algorithm has a default occupancy. It's 1.25 people per passenger vehicle and 1 person per commercial vehicle. We're also considering updating that because the NPM RDS recommendation for that value is 1.7 people per vehicle now. That's just not one that's adjustable in the calculations. It kind of happens in the background.
Next question was, did you compare the car following model results with measured capacities in the field, and how did they compare?
We did not look at any capacity analysis. We have, I mean, that's a really good idea. As we continue our analysis, we'll certainly consider incorporating in roadway capacity into our estimations, but currently we have not done that yet.
And then the final one that we have right now was, I was wondering if it's possible for sharing the set of parameters for the car following model mentioned.
Sure. Yeah, I have backup slides here, which I won't show here, but this gets into all the details of the equations and our default inputs. So I'd be happy to share that with anyone who wants to sniff test this, take a look at it. I welcome your feedback on it.
Well, as the audience has more questions, feel free to throw them in the chat box at the bottom or the Q&A box at the bottom. I think we can go ahead and head on to our next presentation.
Sean, I think you can just begin sharing at this point.
Okay, great, Joanna. Can you see my screen?
We can.
Great. All right, hello, everyone. Thanks for coming today. I wanted to just give you a quick update on some of the performance reporting work we've been doing with the working group as well as the CATT lab. So let's just jump right into that. If you may recall, the last meeting we had, we announced that we deployed the top 10 bottleneck ranking template, very desired by folks. So this meeting, we're announcing the after action reporting package is now available as well. And we're especially excited to release this one because this is an operations kind of template. A lot of the other ones were more planning oriented, but this is the one that operators can use to look at incidents and events that then can be reported to your management, your senior leadership, and others, even the media. And this is an example of an incident summary and incident impact for an overturned gas tanker that occurred on the American Legion Bridge in Virginia. So first part, very simple, lots of pictures and summaries of the event. And then you get into a little more of what the impacts were on the roadway and the network itself and some of the cost of congestion and vehicle hours of delay impacts, how much it impacted on the road in terms of the queuing and some of the takeaways. So we think you'll all be pretty excited about this particular template. So we're just going to walk through this real quick online. So you just, best way to get this is to go to the RITIS logon screen, and up in the upper right-hand corner will be the templates link. You click on that, it takes you to this location. Go to the after action one. Now here on this first step, you would have to log in if you hadn't already, but then you have access to the template downloads, as well as what we call design resources. Now, these are packages of icons and special graphics and tables and things that we've put together just to make your job a lot easier in assembling these templates. And next, we have a series of different use cases that we've collected from agencies and put them here for your use to either look them over and see how they put together information for these different situations. Maybe you like this particular layout or format better. You can use that as well. They're editable, or you can mix and match. You can take pieces from this and add it to this other template we're providing you here. Then we get down and talk about what are the tools that were used to generate this report. So there's 5 different PDA suite tools, as well as using Microsoft PowerPoint. And each tool here has a link to a video tutorial. If you're not familiar with the tool, you can get get some information about how to use it. They're all very simple to use, really. They're all very similar in querying and looking at the results. So once you get a hang of it with one tool, you can pretty much step through all the other tools. They're very similar. And then later on here, we have some design recommendations to keep in mind as you go through building these things. These are from the feds on doing performance reporting. And they're just great things to keep in mind in terms of making things simple, easy to understand, and target your audience with your information. Then we get down to the how-to guide, which is how to create the report. We break it up in this case into 3 sections, doing a front and back cover if you want to, the summary page of the incident, as well as the incident impacts page. So if you click on one of these, it'll take you down and it'll take you step by step through that process of building that report using the tools, using the graphics that we provide. Here's a series of icons that you can grab right off this page. We give you some instructions about grabbing it from PowerPoint. If you don't like these, you want some additional ones. So very helpful information there. And then just walk you through that whole process of grabbing the templates, some of these icons and graphics, and building the report, running through each of these different tools. And we lay it out for you, as I said, step by step. So you come down, you go through all these, like for example, here's running a trend map, which is one of the more popular tools folks like to use because you get an animated map that you can compare different time periods and different conditions. Step you through the query of doing that, getting that information. And then once you do, we show you the map that we developed and using the map controls to build this particular area that we want to analyze. And then you get the results here. And we want to focus, here's that particular bridge location I was talking about. So we want to focus in on this area here and build our map, focusing in on that and comparing it to a day before and a day after that particular incident. And you can see in this case, we want to make a point that there's 3 incidents that are occurring around the same time, almost in the same location. Maybe we better look at this area a little bit closer, see what's happening there. So that is the quick run through of the tool itself. And next, we want to talk about a workshop we had recently, a couple months ago, that Rick Ayers of the CATT Lab ran on creating an effective after action report. So Rick took an ODOT use case, which was a weekend closure, a long weekend, was 4 days of a section of I-84 for some bridge work that ODOT was doing for the Max Red Line, which is a rail project in the area. So Rick stepped through this particular template and laid it out for the folks in the training class, which included some upfront top, very basic information about the project itself in terms of the closure times, what was shut down, how the extent of the shutdown, who was involved, a little closure location map here, an image of the area, and then we get into the tools that were used to analyze the situation. Mark just talked about the causes of congestion tool earlier. So there was 2 looked at. One was identifying that the week prior and the weekend of the closures. Again, here we have that trend map that I was talking about earlier that compares 3 different weekends and then the weekend of that closure. And what's great here, you can, if you're doing a presentation, you can click on this link here, bring up that interactive map, animated, zoom in, click on these different links of interest if you want to see the changes of what's going on. It's a great feature to have built right into your template or your report. And then some additional performance reports down here on the increase in the travel time, vehicle hours of delay, and the delay cost for closing that section of I-84 for that long weekend. What were the impacts there? And this is a great report because executive leadership asked for a report to say what happened and what were the impacts on I-84 for that particular project. So it was very useful for them and very useful for the group. So during that workshop, we did some different polls to find out, the pulse of how the workshop is going, what the information is used for, things like that. So here's what we learned when we did that. About 50 to 60% said they were familiar with the templates and learned it from meetings just like this or from their colleagues. And 17% who use those templates and share them with different audiences or different management, peers, senior leadership to report out on a particular project. We want to get that number up, but the good news is that out of those folks that did share the reports and use them for their presentations, 75% said they made a positive difference in presenting the data. And it's probably a little bit higher because some of them said, well, they weren't sure. So we're happy to see that they're really making a difference in presenting information to the different audiences that they were presenting to. And 93% found the workshop really a valuable resource to their agency. That's kudos to Rick for doing such a great job. And if you want to find out more about that particular workshop and see a video of it or just look at the slides, you just go to the RITIS and PDA Suite page on the Eastern Transportation Coalition's website. You scroll down to this 3-tabbed area, you click on the workshops and working groups, and here it is right there, this creating an after action report. We also did a couple other workshops you may want to check out as well. So what's next? Right now, we're working on another template for holiday travel forecasting. This is another one that's been desired by folks. Right now, we're figuring the deploy of this particular package, which includes the other things I talked about, the template, design resources, agency use cases, and how-to guide, will be in about 4 to 6 weeks. So we'll let you know about that. And included with that deploy, we've tried a couple of different layouts that are different from what we normally develop. And this one on the left is for Thanksgiving weekend, but this past year, using an illustrations, scenic elements of that are available in PowerPoint. They have a group of different illustrations already put together. You just grab them and pop them in there. You could use this particular one as is. You can grab elements from it and put it in your own. We also have a page in our design resources document that explains how you get these things, how you put them together, how you can break them apart even, and colorize them, things like that. Very simple to do. It's all laid out for you. And here's another example of using some stock images and icons from PowerPoint to create a different look. Just a little bit simpler presentation. The information might speak better to the travelers on the holidays. So we want to include that for you, just in case you want to use that. And of course, putting these graphics in your social media pages is really great because it just helps tell the story to the folks. They can look at it and get an idea instantly about when and when not to travel during those holiday periods. So we think this is a great addition for your all social media pages. So keep an eye out for that deploy announcement that will be coming soon for this particular holiday travel forecast template. Once we do roll out that and get that to developers, we want to start working on some work zone reporting packages. This is an older version that we put together and thought it told a pretty good story, but we want to relook at this as a working group and really get it down to what speaks best to your audiences. And we have a lot more information now. We have some input, say, from Matt Glasser, who has been going with me back and forth on, what should we be including in these things? What makes sense? What really tells the story with respect to a work zone? And one of the things we're also going to be doing is to have some synergy between our group and this other group that you may have heard about called the Automatic Work Zone Reporting Working Group, which is part of the RITIS Enhancement Working Group. We just had a meeting a couple weeks ago. It went really well to get people talking about what is important to them in terms of reporting out on work zones. So we had a really good group discussion, got some good intel there. And as we go through this scoping design process, we'll have that synergistic effect between the two groups. So as we build our work zone templates, we'll be able to customize them a little bit better to what people want. We'll put them out there, people will use them, and that in turn will help from feedback, maybe make the automated work zone reporting tool better. So Bob's going to talk a little bit about that in a second. And then finally, we have an upcoming RITIS workshop, session number 4 that I wanted to tell you about. We have the date, we have the time. We have a couple of topics that we think would be great, and we haven't decided about which one we want to show. So we'll be announcing that shortly. I'm assuming it's going to be for the, the email that we send out that summarizes this meeting. And we'll talk about the topic there at that time. So that's all I have for you today. Matt, back to you.
Appreciate it, John. I think to keep things moving, we have a couple questions in the Q&A box, but we'll go ahead and head over to the RITIS Product Enhancement Working Group and let Bob take it away from here.
Great, thank you, Matt. Let's go to our next slide. We're a little behind time, so I'll try to move through these pretty quickly. So yes, our RITIS Product Enhancement Working Group. What's our mission? It's kind of a pooled fund group to pay for all these great improvements and additional features in RITIS, and to just help the CATT lab figure out where to focus their resources and what projects to prioritize. We need a steady funding stream and want to share information between DOTs and MPOs and other agencies and help each other out. Next slide, please. Okay, so our general timeline, last summer, we finalized the enhancements to move forward with. This was a process that started when Michael had put together a list of, I think, over 30 different types of enhancements and rough costs associated with each. Some were relatively quick and easy projects, others were much more involved. We discussed all of these and whittled everything down to about 24 different projects. We voted on them back in May of 2022 to prioritize all the work going forward. So here now, winter 2023, we formed this working group for the automated work zone reporting to help determine what features are most important to incorporate. And then you can see the cycle starts again with new work and new agency commitments. So far, we've got 5 DOTs that have contributed funds, and we hope to get a lot more. Next slide, please. You might have seen this chart before. I'll go through part of it pretty quickly. We basically have 2 categories of funding. On the left is funded through the DOTs on our enhancement working group, and all these projects have been rated very important. And the box on the right are enhancements that we still need some funding for them. Some are already in development, as you see, and we're hoping we can get more funding sources because a lot of these are multi-year efforts. But for sake of time, we'll skip over some details of that. Let's just go to the next slide, please. Okay, and this one you saw, this one's already done. The aerial photography in RITIS maps. This operates just like in Google Maps, where you can toggle between the map and the satellite view. So that's already in use and is very useful. Next slide. So new speed tile layer options. We've got 4 options currently. The goal here is to give new layers and new options and just generally declutter the map. So you can have the option of only showing certain things like you see here on the list. Next slide. You just heard John talk about these. Everyone likes reporting templates. They're very popular and relatively low cost. We've got more, as you heard, we've got more in development. John talked about all the templates on the RITIS site in the after action reporting package. So all this work is in progress and continues. Next slide. And causes of congestion, you heard about this as well. Mark mentioned the CCG tool earlier when he was talking about the user delay cost. And I think it was also presented at a previous RITIS user group meeting. This is just a deeper dive on the different causes of congestion, looking at all types of causes, incidents, weather, work zones, signals, recurrent congestion, holiday travel, multiple causes as well. That's important. As you see here, they're going to update the causes of congestion weekly, so you won't have to wait as long between updates. And also adding coverage, I think recently for 10 new states, with more on the way. Next slide. Sharing of dashboards and reports. This isn't necessarily that easy a thing to do because it requires certain credentials and security clearances and things like that. But the goal here is to allow an organization to share their dashboards with whoever they designate. Internally first within their agency, that will be easiest, but ultimately we hope to go outside agencies as well. Next slide. And like in that earlier chart with the box on the right, this has been started, but it's more of a stretch goal. It's still a ways off with these speed bins visualizations, and I think they're competing with other priorities and staffing availability. But ultimately, we hope to end up with much more detail on speeds along a specific defined corridor, so we can better identify problem areas. Next slide. With the safety analytics, we're still getting data for this, as we saw on that other chart. But there's several different visualizations that we're looking for, like the crashes by type, whether it's fatalities, injuries, property damage only, and then looking at crashes by month and day and time of day, driver age, road condition, vehicle type, all those different types of metrics. Next slide. And the map click corridor selection. This is a new feature still in development. This is pretty cool, I think. This is going to allow you to select a length of road through the map, which is much easier than selecting those specific to and from TMC segments in the drop-down menu. I know when I do that, sometimes I have to guess at what segment will cover the end of the roadway, and sometimes you guess right, sometimes you don't. Then you have to go back to the drop-down. But with this new way, you should be able to just click on the start and end points on the map of the road, and get all the needed segments will be chosen automatically for you. So that's still under development, and we're looking forward to that, definitely. Next slide, please. And then the automated work zone reporting. You heard about this a little bit already from John. Looking at a whole range of possibilities and options, from the simple to the complex. You heard about the work zone reporting templates, and thanks John for all your work on these specific projects so far. I think they're providing a good base for making a standard automated tool in RITIS available to everyone that we can customize with features and metrics that are most important to everyone. Next slide. And so again, with this, we've formed a group. We had our first user meeting on January 18th, discussed what the most important metrics would be. Some of these would be that we came up with: total travel time through the work zone. When does the queue start and end? The length of the queue, both in terms of actual mileage, and then time-wise as well. How long does the queue last? Does it vary throughout the day? Does it vary across different days? So now, after the CATT lab comes up with some initial internal designs, they'll come back to our group and we'll review again. Like this chart shows, we'll go through several iterations and then ultimately decide on the final product. So that's still in progress here. Next slide. And so next steps. Like I said, we've established this automated work zone group, and we'll keep meeting on that. But our next full enhancement working group meeting is March 2nd. We're always looking for more participation, including financial participation. As I mentioned before, we had 5 state DOTs that have contributed to the pooled fund effort for RITIS enhancements. Georgia, Michigan, Oregon, Virginia, and my own Massachusetts DOT. So I encourage more DOTs to participate. You can use federal SPR funds, at least we did here in Massachusetts. And most of us are so far are contributing between 50K and 100,000 a year. But any little bit helps, and the more support we can get, the more we can keep these improvements and new features in RITIS, the more we can keep them coming. So so that's the pitch. That's the sales pitch for today. And I think that that's it.
Appreciate that, Bob. I think we'll just go ahead and hand it right over to Michael.
Yep.
All right, so we'll keep this quick and just go over some of the new things that we are working on or have recently developed. Next, please. So if anyone really wants to know everything that's going on with new development in RITIS and all the RITIS related tools like Probe Data Analytics Suite, TRIPS Analytics, Signal Analytics, whatever, you can go to each one of those websites and there is either a what's new flag or there is a release notes tab. Sometimes the release notes are hidden down at the very bottom in a link. But there you can see the laundry list of things that we've been working on and have deployed thus far. So since the last user group met, we've done a lot of enhancements and updates to the security of RITIS. That's both the application side and the hardware side as well. We've also been adding a lot of new sensors and data sources, especially in the Northern Virginia region. So Transurban, it's the toll, the expressway toll group in Northern Virginia. We now have their DMS and event data on the traffic map. We've also added all of the Virginia Wavetronics and related speed and volume sensors. Brand new to RITIS, we have some bike counter data in there. And I think we're still working on some pedestrian counts in a few places, but the bike counter data is new. We've also added some bike share data in there. And then with here, for those of you who use HERE's data instead of NRIX or TomTom, we now have the ability to take their what's called topological subsegment data. It's smaller, finer grained segmentation than like a TMC segment. And those their finer granularity data now works in our congestion scan tools, quarter time comparison, trend maps, performance charts, performance summaries. And we don't have it on here in the list, but it also works on the a couple of other tools in Probe Data Analytics as well. So please go and check those out. And of course, we added the reporting templates that John just mentioned. Next slide. I think the biggest new tool that's been deployed is for those who use the signal analytics, the intersection analytics. We now have this thing called intersection matrix that allows you to break out the performance of different turning movements at different intersections by time of day, not just an aggregate measure, but really saying what time of day you might have particular problems for particular turning movements at an intersection. This is brand new. We will probably do a separate presentation on how to use this and how to interpret the results at some point in the future. And the last thing I want to mention, we don't have a slide on this, is that coming up on Saturday, February 18th, the CATT Lab is going to do a major hardware upgrade of some of the servers and some of the software on the servers for our Hadoop cluster. That's our distributed file sharing system that runs a lot of the probe data analytics and probe data tools. What this means to you all is probe data analytics will essentially be unavailable for several hours on Saturday, February 18th. And then because the system will be down for several hours, once the system comes back online, it will take a few hours for all of the data to be reprocessed and made available again in the tools during that downtime. So expect the system to be, kind of diminished between Saturday and Sunday, February 18th and February 19th, as everything comes back online. Now, if anyone is aware of anything major that is planned for that weekend where we might need to consider holding off on that upgrade, please let us know. Otherwise, we're gonna forge forward, and we'll put a message of the day up on the website as well, so people know that, that this is coming. Next slide, please. And so this is the portion of the meeting where we open up the floors and we ask people to complain. We want you to tell us what it is that you wish we did or wish we had the capability to do in the RITIS tools that we don't have the capability to do right now, so that we can make things better. If you don't complain, things won't get any better. Also, if you are interested in providing a presentation to the RITIS user group at some point in the future on something that you are doing that you think is worth sharing, we want to know about that as well. So I will stay silent while people type in the Q&A box or the chat box how we taking complaints. If anyone wants to request some sort of new feature, please talk about it. And while we're waiting on that, we're going to put up a couple of polls that we want you to respond to as well. So Matt, you want to go through this?
Why not? So first poll question, and you can read them both on the screen or you can just listen to me. What kind of things are you currently doing with RITIS? Is it planning and operations, presentations, project funding, and justification? That kind of input helps us understand what we're dealing with, as well as bringing those types of projects in for future presentations.
If anyone would like to verbally ask a question or make a complaint to Michael, you can just raise your hand and you'll come to the top of the list, and then we'll know that you in fact would like to speak.
When we get to the next poll question, there will be time to enter in stuff there as well about what frustrates you.
I think we can probably keep that poll up, and I think we're going to bring the next set of polls up, Matt, if that's okay. We don't have a lot of time, and I want to give people an opportunity to write in.
Let's do it. All right, we're going to do all 5, 6, and 7 all at the same time, so that way we can work through them. Number 5, start complaining. What frustrates you most about RITIS? Is it and that's all all the above? Is it the live map, when the live map is driving you crazy? What about the PDA suite, trip analytics, or the signal analytics? Next piece, what features or functionality, if added to RITIS, would make your life significantly easier? As a consultant, also, I'll raise my hand and say, think too about us, in the sense of we would love to run reports more efficiently for our clients. And finally, what are some examples of important things your agency wants to know that you wish RITIS could help you answer?
And take the
Michael,
time
could you
now.
figure out a way to go ahead, Joanna.
So if you can take the time now, the information will get in front of Michael as well as the whole group, and they can look at that very quickly after the meeting. So
Michael, can you guys figure out how to take a budget and run it through RITIS and come up with the best projects for us, so that way we don't have to argue back and forth.
You know, you joke about that, but that is what we call what if scenario planning and project prioritization. Greg Jordan with the CATT lab has been playing around with some algorithms, and I think Mark Franz is also involved in trying to figure out how to do that, especially for like the MAP 21 PM3 metrics, and trying to set targets and then trying to prioritize projects based on the target that you've set. I don't think it's very far along, but we have some like internal mock-ups of what we'd like that to look like. But that would be complex. It would require a lot of inputs from agencies as well.
Perhaps you could do some fusion with Chat GPT. And,
while people are typing, I see Haroon has said he wants to see, or they want to see trip analytics tool available for planners in Northern Virginia. Hey, I'd like that too. Trips analytics only works if there's data available from third party. So talk to your colleagues at VDOT. Someone would need to either, someone would need to purchase a data set from a vendor, and that could be, like an NRIX or a WEJO or even the National Household Travel Survey, something like that. That has to exist first, and then we can make trips analytics available. But yeah, we'd love to do that.
And Haroon, GDOT probably has the official answer here, but they last year, bought a statewide license and shared it with their, the other agencies within the state. And when they made the budget ask, they were projecting a 2-to-1 benefit cost. And I think it's come closer to, a 3 or 4 to 1 in direct agency savings, not like hypothetical saving lives or saving travel time. So that might be a resource that you can talk to them about seeing what they looked at, because I know that when you're agency to agency, goes a lot further than consultant or contractor to agency. And I think certainly we're a bit over time at this point. So if you need to hop off, certainly understand. But if you'd like to hang on, pester Michael, raise your hand, yell at him. We are happy to oblige. And while we're doing that, let me just say thank you to everyone for participating, both as a listener as well as to all of our speakers, Denise, Joanna, Michael, Andy, Bob, Mark. Love hearing from you guys. Couldn't do it without the support team over at RITIS and the CATT lab. So thank them and pass our appreciation along. Esther, I'm sure I've missed something, or Joanna, I'm sure I've missed something. So if I have, please feel free to chime in.
Yes, thank you. You really didn't miss anything, but just to remind folks that like other RITIS user group meetings, the presentations will be posted to the coalition website along with a Q&A summary. So all those questions that you're putting in will get summarized, and you'll get a mailer when that is all available to you. And as John said, hopefully at that point, we'll have a topic and a registration link for you to register for the next RITIS workshop.
Michael, I think I know it doesn't come directly out of you guys. I've always been appreciative of the trainings that have been done at the end of the month. I would certainly raise my hand to say I think that there is a growing appetite for the Trips Analytics Suite. So I'll continue to pester for those.
Awesome. Thanks.
think we can officially end the meeting at this point. So again, thank you to everyone. We will keep the polls open for a couple more minutes, just in case there's anybody who's still typing or would like to, provide anything. No. Okay, thank you.